Alright guys, today we're going to be covering 2.6, congruent supplements and complements. Our learning target for today is I can prove angles are congruent by using 4 new theorems. So with that being said, let's go ahead and get started. So, to begin, let's say angle 1 and angle 2 are supplementary angles to angle A, meaning angle 1 plus angle A equals 180 degrees, and angle 2 plus angle A equals 180 degrees. Now, if this is true, what can I say about the relationship between angle 1 and angle 2? Well, if we know that angle A is equal to 70 degrees, then we can go ahead and determine that angle 1 is congruent to angle 2. And that's because they're both equal, their sums are both equal to 180. Now, on top of that, they're also supplementary to the same angle. So angle A needs to be the same regardless. Now, if I go ahead and I take this example and I plug 70 degrees in for angle A, we can see, so again, I'm just plugging 70 degrees in for each of these. We can see that through the subtraction property of equality, we'll get angle 1 is equal to 110 degrees, and also angle 2 will be equal to 110 degrees. So therefore, we can conclude that they're going to be congruent to each other. They're going to be the same measurement. And of course, that makes sense because if I'm subtracting the same amount from 180 degrees on both of them, it should equal the same exact number. So that leads us to our first theorem of the day. And that is, if angles are supplementary to the same angle, then they are congruent. So on this last one, we saw that both angle 1 and angle 2 were supplementary to the same angle, being angle A. And we found out that those two angles, angle 1 and angle 2, were congruent. So that's where this theorem comes from. So go ahead and take a second, pause the video if you need to, and write this down. If angles are supplementary to the same angle, then they are congruent. Now, at this point, we're going to go ahead and show you guys one of these proofs. Now, feel free to write this down if you'd like, but I'm just going to go through the information slowly and explain how we go through these types, because this will lead us to a shortcut near the end of the class today. So let's go ahead and begin. Given angle 3 is supplementary to angle 4 and angle 5 is supplementary to angle 4, we want to prove angle 3 is congruent to angle 5. So to get started, we always start with our given information. So up here we have angle 3 is supplementary to angle 4 from the given information. So therefore I can say angle 3 plus angle 4 is equal to 180 degrees. Because if two angles are supplementary, then their sum is 180 degrees. That's the definition of supplementary angles. Now, I'm trying to solve for angle 3 because we want to prove that angle 3 is congruent to angle 5. So I want to get angle 3 by itself on the one side of this equation. So to do that, I go ahead and I subtract angle 4 from both sides using the subtraction property of equality, which will give us angle 3 is equal to 180 minus angle 4. So let me go ahead and highlight that in red for a second real quick, underline that for you guys. Now, in blue, this is the same exact thing, except now I'm using angle 5 and angle 4. So I can say angle 5 is supplementary to angle 4. Therefore, angle 5 plus angle 4 is equal to 180 degrees. Same thing, definition of supplementary angles. Now, again, we want to prove angle 3 is congruent to angle 5, so I want to solve for angle 5 on one side of my equation. To do that, I subtract angle 4 from both sides using the subtraction property, which will give us the measure of angle 5 is equal to 180 minus the measure of angle 4. So let me go ahead and underline that as well. Now, if we look at the measure of angle 3 and the measure of angle 5, the equation in black and the equation in blue here, that are both underlined, the only difference is that one is set as angle 3 and one is set as angle 5. The rest of the equation is the exact same. They're both equal to 180 minus angle 4. So therefore, they have the same exact measurement. They're equal to the same thing. So since they're both equal to the same thing, I can say that they are equal to each other. So the measure of angle 5 is equal to the measure of angle 3 because they have the same measure. So essentially, I just took the second part, 180 minus the measure of angle 4, and I substituted in for the measure of angle 5. So I just moved that entire chunk, measure of angle 5, and I replaced it with 180 minus the measure of angle 4. Now, if these two angles are equal, because they have the same measure, then they should be congruent. So therefore, angle 5 is congruent to angle 3, which finishes off our proof. So again, we can see that when we're trying to prove for these, we're just going to go ahead and solve for this angle and then solve for this angle. From there, we compare those answers. All right, let's go ahead and check out our second theorem. It should be fairly similar to this one. There's only going to be one slight change. So theorem number 2, if angles are supplementary to congruent angles, then they are congruent. So the major change here is that it used to be to the same angle, but now it's to congruent angles. So that's the main difference. So this time I'm going to have 4 different angles that we're looking at. So if angle 1 is congruent to angle 2, so let me go ahead and just draw those real quick. So here's angle 1. I could do better than that. Here's angle 1, and then here's angle 2. And these two are congruent, because that's given. And we know that we have angle A, which is going to be supplementary to angle 1. So here's angle A. And then we also have angle B, which is supplementary to angle 2. Well, if angle 1 is congruent to angle 2, and angle 1 is supplementary with A, angle 2 is supplementary with B, then we are able to conclude that angle A and angle B are congruent to each other as well. So these two angles will also be congruent. And I can draw that in. So that is what the second theorem is. So now that we're looking at 4 different angles here. So this is if 2 angles are supplementary to congruent angles, then those angles are congruent. So let's go ahead and try and prove this one. So can you do it? Go ahead and pause the video, try this one out on your own, and then we'll work through it together. That way you can check your work. All right, so I'm going to work through this one as a paragraph proof. So go ahead and take a look at this. We have angle F is supplementary to angle G, so that's our first given. And if that's the case, then I can say angle F plus angle G equals 180 degrees, because that's the definition of supplementary. I can say the same thing with angle H and angle J. So those two angles are supplementary, so therefore they are, their sum is equal to 180 degrees. At this point, we're trying to solve for angle F and angle H, because those are the angles I want to prove are congruent. So for my blue equation, I go ahead and I subtract angle G from both sides, which will give me angle F is equal to 180 minus the measure of angle G. That's the subtraction property of equality. We do the same thing with angle H, except this time I'm subtracting angle J from it, because again, I want to solve for angle H, which will give me angle H is equal to 180 minus the measure of angle J. Again, same property. Now, the last thing that's different from this one is that they tell me that angle G is congruent to angle J. So angle G and angle J are the same exact measurement, so they are congruent. And since that's the case, because that's given to us, then we can assume that angle F and angle H have the same measurements and therefore are congruent as well. Because if these are the same measure, they're congruent, and I'm just subtracting the same amount from 180 in both these angles. If that's the case, angle F and angle H will have the same exact measurement as well. All right, so those are the 2 main ones that you guys need to memorize. The next 2 theorems are the exact same, except now they're complementary angles. So if angles are complementary to the same angle, then they are congruent. This is almost exactly the same as theorem 1, except now we're dealing with complementary angles. And we know complementary angles will add to be 90 degrees. So it works for 2 angles that will add to be 180 degrees, as well as for 2 angles that add to be 90 degrees. All right, so let's go ahead and continue on. I'll show you guys a quick proof of this. I'll need to draw a picture for it though. So angle 3 is complementary to angle 4, so let me go ahead and draw this up. So we know we have angle 3 here, and we have angle 4, which is complementary to it. On top of that, we have angle 5, which is complementary to angle 4 as well. So we have angle 5 here, and that's also complementary to angle 4. So we want to prove that angle 5 and angle 3 are congruent to each other. So that's our main goal here. So setting up, angle 3 is complementary to angle 4 from the given information. So therefore, angle 3 plus angle 4 equals 90 degrees. And I just realized that I should have made this 90 degrees instead, so let me go ahead and change angle 4's look. My apologies. Here is angle 4. Again, they're going to add to be 90 degrees this time, not 180, because they're complementary. So Angle 3 plus angle 4 is equal to 90 by definition of complementary angles. Two angles who are complementaries have a sum of 90 degrees. Now, I'm trying to prove that angle 3 is congruent to angle 5. That's our main goal. So I solve for angle 3. So angle 3 plus angle 4 equals 90. If I subtract angle 4 from both sides, we get the measure of angle 3 is equal to 90 degrees minus the measure of angle 4. That's done through the subtraction property of equality. I can do the same thing with angle 5. So same type of setup. Angle 5 is complementary to angle 4. Angle 5 plus angle 4 equals 90. And then again, I'm solving for angle 5 because those are the angles I want to prove are congruent. So therefore, I have angle 5 is equal to 90 minus the measurement of angle 4. Since they both have the same measurement, again, if we look at this, for measurement of angle 3, that's equal to 90 minus the measure of angle 4. For angle 5, that's equal to 90 minus the measure of angle 4. They're the same measurement. They're equal to the same amount. So since that's the case, they're equal to each other. So I can say angle 5 is equal to angle 3 because they have the same measurement. Therefore, they are congruent. Angle 5 is congruent to angle 3. And that is our proof. Again, very similar to the first one. The only difference is that we're just changing it to complementary, and as a result, these are all changing to 90 instead of 180. That's the main difference. Everything else is pretty much the same. All right, as for theorem 4, again, it's very similar to theorem 2, except now we're dealing with complementary angles once again. Now, I'm not going to go through this proof because, again, I've already gone through it 3 times essentially. And just keep in mind, this one's just like theorem 2, except now it's complementary. So all the 180 degrees, they change to 90 degrees. All the words that say supplementary now change to complementary. So those are the main differences. But again, just memorize these 4 theorems. Essentially, you just need to memorize 2, and remember that it works for supplementary and complementary angles. If you do that, you'll be very well off in terms of these types of problems. So again, I'm going to reemphasize, memorize the 4 theorems. If you do that, you'll be in a much better position. All right, now, all these theorems that we just covered, theorems 1, 2, 3, and 4, all lead to a new shortcut for us. So I'm going to go ahead and show you guys the shortcut. Here it is in a proof. So given angle 1 is supplementary to angle 2, and angle 3 is supplementary to angle 4, and also angle 1 is congruent to angle 4, we want to prove that angle 2 is congruent to angle 3. So, looking at this, we want to prove that 2 angles are supplementary to the same angle are also congruent. So, again, our first 3 statements are all of our givens. So, angle 1 is supplementary to angle 2, angle 3 is supplementary to angle 4, and angle 1 is congruent to angle 4. All given. Now, with this, we can now use our shortcut. So, we see that 2 different angles are supplementary, and therefore, I can say if angles are supplementary to congruent angles, because again, they're supplementary to angle 1 and angle 4, and I know that those 2 angles are already congruent. So if angles are supplementary to congruent angles, meaning our blue angles, then they are congruent, meaning our purple angles. Let me go ahead and just underline this in the colors that are shown on the diagram. So if angles are supplementary to congruent angles, and when I say the angles are supplementary, I'm talking about the purple and the blue angles. If these 2 angles types are supplementary to congruent angles, then they are congruent. So this is shorthand that you guys can use. This is, of course, a conditional statement. If this occurs, then this occurs. But for short form, if you guys are writing these out on paper, then you can use the short form and say supplements of congruent angles are congruent. And that works perfectly fine as well. Again, this is just theorem number 2. So if you guys need a refresher, you can go back to theorem number 2. This is it written in a 2-column proof, as well as a shortcut to make sure that we don't need to see that subtraction property every time. Now, of course, you can still do that subtraction property every time, but you don't need to. And if you want to save time, I encourage you guys to use the shortcuts because those will always help you out on the test and save you quite a bit of time. All right, with that being said, we're going to go ahead and move into proofs. We got 2 of them today, so I'm going to give you guys time to work on each of these. So please pause the video, Try out this proof on your own, get as far as you can, and if you get stuck, go ahead and start watching the video. If you finish up the proof, then go ahead and unpause the video to check your work whenever you're ready. All right, so for this proof, I'm going to go ahead and do it in two different ways. The first way is using the shortcuts that we've just learned. The second way I'm going to do it is I'm going to teach you guys a little bit about vertical angles. Now, vertical angles will be covered in a video about 2 videos down. We have a couple days before we cover that lesson. So I just want to make sure that you guys see it beforehand. On top of that, it'll be really useful for you guys just because this will be on a Wednesday class, so you guys won't actually see me that day. On top of that, vertical angles will be used constantly. It's one of our easier theorems to remember, but it's very useful in determining which angles are congruent to each other. So we'll go through that in just a minute. As for this proof, because you guys have been waiting, I'm going to go ahead and start off by saying the diagram is shown because that is given to me. So diagram is shown, that is given. From here, we want to prove angle HFE, so this angle, is congruent to angle GFJ, this angle. So we want to prove that these two angles are congruent. Now, these two angles are known as vertical angles. Vertical angles appear whenever two lines intersect each other. Vertical angles are just on opposite sides. So angle HFE and angle GFJ are vertical angles. Likewise, angle HFG, this angle right up top here, and angle EFJ, this angle down below, these two are vertical angles as well. So keep that in mind as we go through. And remember, vertical angles are always congruent. So you'll see that when we actually prove this, you'll be able to look at it and be like, oh, those were actually congruent. I can see that now. So what are some things that we can assume from the diagram? Because we are only given the diagram as shown. Well, looking at this diagram, I see that we have some straight lines, which means that we have some straight angles. So I can go ahead and start off by saying angle EFG, so angle EFG, and, again, this is the symbol for and angle HFJ are straight angles. That's what we can start with. Now, why can I assume that? Well, because it's assumed from the diagram. Again, there's very few things that we can assume from the diagram, but straight angles are one of them. And always look for straight angles if they give you a diagram. Now, if those angles are straight angles, again, this angle up top and this angle up top are straight angles, then I can assume that we have some complementary angles as well. So next up, I can say, for number 3, angle EFH and angle HFG are supplementary. So angle HFE, the angle that we're trying to solve for, and the angle up top, angle HFG, those two angles are supplementary to each other. Now, the reason that we can say that is if two angles create a straight angle, then they are supplementary. Now, next I'm going to focus on my other straight line here, so angle HFJ. Now, see that I took the purple angle on top. That means that I want to take this angle once again, because I want them to share a common angle. So that means I'm not going to take this angle down below. I'm going to ignore this angle completely. I'm just going to focus on the two angles up top and the two angles up top. So now I can say for number 4, angle JFG and angle HFG are supplementary. So again, I'm saying this green angle and this purple angle that we already drew, these two angles are supplementary as well. The reason that we can say that is the same exact reason as 3. So I can just put same as 3. If two angles create a straight angle, then they are supplementary. Now from here, we're pretty much done with this. So I can say for number 5, looking at number 5, we have two of these angles that should be the same. And we can use our shortcut now. So I can say straight away, angle HFE is congruent to angle GFJ. The reason I can say that is supplements of congruent angles are congruent. So we have, again, these supplements, the green and the purple, and the green and the purple. They're supplements of the same exact angle, angle HFG. Therefore, they are congruent to each other as well. This is theorem number 1, the first theorem that we covered today. All right, next up, we have our second proof. Go ahead and pause the video if you need to. Try out this proof on your own, and then we'll be going through it together. Now, before you do that, here's the vertical angles once again. So the purple angles are vertical angles. The green angles are vertical angles. So just keep that in mind as you go through these. I just want to make sure that we see what vertical angles look like before you actually cover a lesson on them. All right, here is our final proof of the day. Given KM is perpendicular to MO, PO is perpendicular to MO, and angle KMR is congruent to angle POR, we want to prove angle ROM is congruent to angle RMO. So first, I'm going to go ahead and start off with all my given information. So I'm going to put all my givens in one statement. KM is perpendicular to MO. We have PO is perpendicular to MO. And we have angle KMR is congruent to angle POR. Those are all given. Now, what does it mean when we have perpendicular line segments? Well, that means that we have right angles, because two lines that intersect perpendicularly intersect at 90 degrees. So I can go ahead and draw right angles right away. And for number 2, I can say angle KMO and angle POM are right angles. And again, the reason that we can say that is if two segments intersect at 90 degrees, or intersect, let me just put are perpendicular, because that's what's given to us, right? We're given perpendicular. So if two segments are perpendicular, then they form a right angle. Now, we also know KMR is congruent to angle POR. So I can just go ahead and draw that right away. Angle KMR is congruent to angle POR. So that's right here. That's this green section. So I can just draw those. That was from our given information. Now, at this point, if I know that these are right angles, we already said that they're right angles, then we know that they're creating some complementary angles in there as well. So I can go ahead and bring that up next. I can say for number 3, angle KMR and, don't forget that's the symbol for and angle RMO are complementary. Angle KMR and angle RMO, let me go ahead and fix that M, that way it doesn't look so strange. RMO are complementary. Whoops, sorry about that. The reason that we can say that is if two angles create a right angle, then they are complementary. If two angles create a right angle, then they are complementary. Now, I can do the same exact thing with these other two angles, with my other right angle. So let's do that. Number 4. Angle POR and angle ROM are complementary. The reason is the same as 3. Now, if that's the case, we can go ahead and finish this off, because again, this is looking very similar to theorem number 4. So let's finish this off right now by saying number 5, angle ROM is congruent to angle RMO. And the reason for that is because first off, I know KMR and POR are congruent. We can see that in our given information right up here. They're congruent to each other. And those congruent angles are complementary to these two angles here. Now, if these two angles are congruent, which they are, and they're complementary to these two angles, then these two angles should also be congruent to each other. So again, I can use my shortcut here. For number 5, I can say complements of congruent angles are congruent. So complements of congruent angles are congruent. And with that, this proof is now complete. We have now proven that angle ROM, this purple angle, is congruent to angle ROM is congruent to angle RMO. So these purple angles are now congruent, which is what we were trying to prove. So this theorem is now complete. All right, that is it for our learning target today. Our learning target, again, is I can prove angles are congruent by using 4 new theorems. We've now finished 2.6. You guys do have homework in Schoology, due Sunday night at 11:59 p.m. If you guys have any questions, just let me know. Other than that, thank you guys so much for watching. I hope they